Hello everyone, in the lecture of IC engine fuel and lubricants. In previous lecture we have discussed the qualities requirement for the engine of different types of fuel, CI engine and SI engine fuel, its rating and its additives and dopes, some gaseous fuels like LPG we have discussed. In this lecture we will discuss the remaining gaseous fuels, alternative fuels for IC engines, biodiesel, diethyl and alcohols. So, in last lecture we discussed the LPG, now the CNG which is known as natural gas, it is known as the compressed natural gas, abbreviated as CNG, and its pressure varies from 7 to 21 bar, boiling temperature is very less -160. You can see the flammable range is 5 to 15 range 5 to 15%. And but it is safer than the LPG as it is having high auto ignition temperature 540 degree Celsius, but reduces power if you use as a replacement for the engine, the power is lost, it is 10%, it is lighter than air and disperses more quickly, that is why it is safer for the utilization, stored at 20 to 25 megapascal and it is having the calorific value of 50 megajoule per kg. This is the composition having maximum amount of methane, this is major composition is methane of CNG which is about 95% and remaining one is ethane, propane, then butane, carbon dioxide, nitrogen and others, but the main composition is of methane. Now, come to the another gaseous fuel, hydrogen is the simplest to use, most abundant element on the earth, it is having very high energy and burns with almost no pollution, because if it burn H2O with air sorry with H2, if it burn with air it will give you H2O, but because in air there is nitrogen, so it produces and NOx emissions also. So, this problem is there and its high cost, storage cost and also its safety issues are there. The lower calorific value of hydrogen is about 120 and can be stored physically as gas or liquid. It have electrochemical property which is used in fuel cells, high auto ignition temperature just like CNG, and the most important which is the responsible for its safety, it is a broad flammability from 4 to 74%. So, it is very wide. So, somewhere if it is leaked and you start a heating source somewhere in the given space, you cannot feel and there will be it can catch fire, and its road octane number is about more than 130. These are the comparable properties of hydrogen, its calorific value as compared to CNG, petrol, diesel. You can see these are the some properties, its density very less as compared to petrol, LPG, and phase standard, it is gas, auto ignition temperature limit, which is for petrol it is between 250 to 260 and for LPG it is very high, but here this is 500 to 540 and it diffuses very fast. Diffusion coefficient, diffuses means it leaks very fast and its high flammability range are the they are responsible for its safety, because it can catch fire, it is not so easy to handle it. These are the advantages of this hydrogen, non poisonous and non toxic, and challenges of using we have discussed. What are the challenges? You can see these are hydrogen comparison flammability range of comparative fuels. You can see that this is the highest 4 to 75%. Then for methane it is, methane means CNG, you can see, because methane is the main component, it is 5.3 to 15%, 5 to 15%. Then propane is having 2 to 10 approximately, its flammability range, and this methanol, which is a good SI engine fuel. So, it is having this flammability range. Then gasoline, petrol, it is having flammability range from 1 to 7.6%. Then diesel is having least among this 0.6 to 5.5%. Then biogas, biogas is bio CNG, also you can say it is bio CNG type thing, and it is having this methane 50 to 60%, CO2, then hydrogen, nitrogen is a composition of all the components, small traces of other gases, and this is having its value, the clean and slow burning gas having value between 500 kilocalorie per its calorific value. The octane rating of biogas is near about CNG, because it is also having methane. We can also go for enriched biogas, enriched biogas, where we purify this biogas and enrich the composition of methane, then it is known as bio CNG. And the drawback of biogas is the presence of carbon dioxide. The engine performance can be improved by reducing this carbon dioxide percentage in the biogas. Now, come to the alternative fuels for diesel and SI engine fuel. SI engine, biodiesel is one of them. We have introduced that in the last lecture. Biodiesel, it can be used in some percentage. It is methyl or ethyl ester of fatty acids produced from the vegetable state, vegetable, edible or non-edible types. It is having better lubricating properties, much higher cetane rating, and very low or near 0 sulfur in as compared to the diesel. So, it can be used in experimental work. We have done many things. It is used from up to 20%, it is recommended, but we can also go for beyond it. But it up to 20% it has been reported that it gives better air if it is blended into the diesel. It is having lower calorific value. Cold flow property is very problem creating, because it is at less temperature it freezed, the components in the biodiesel is freezed. So, the cold flow property is very big challenge for it. So, we can go for different methods. In coming slide we will discuss, because these are the properties of the CI engine, because these are the properties of the CI engine, advantages and disadvantages. It is the advantages of the CI engine as compared to the SI engine in lower NOx, lower hydrocarbon, lower carbon dioxide emission to SI engine. But disadvantage of the diesel engine is higher NOx and high level of smoke and particulate matter, PM for particulate matter. These are suspended particles. There may be PM 10 or PM 2.5. These are the size of the particle in micron. So, the biodiesel is produced with the help of a chemical reaction in you can see this equation. This is triglycerides, then with the help of some catalyst, acid catalyst and base catalyst we can go for, and this process is known as transesterification. this process known as transesterification. So, it is formed with the help of some catalyst, with the help of some catalyst you can go for this chemical reaction. So, biodiesel is a can be a good solvent for the diesel fuel in the diesel engine. This is some study. I have just showing this slide because we can go for different types of seeds, either non edible or edible. So, we will not go into the detail, just like mahua, saijan, jaitropa, karanja, semal, kanchar, palas, jungle jalebi, etc. So, you can see that if you take the 100 gram of mahua, the recovered oil known as SVO 48% yield, it is having 4.4% free fatty acids. These are the properties cloud point and freezing point. So, it shows some information about different types of non edible oils. To overcome the different because there are some limitations for using the biodiesel. So, many researchers suggested the using of different type of biodiesel blend in varying proportion at a time in different composition. You can go for preheated biodiesel. You heat the biodiesel before injection into the combustion chamber, preheating by use of some exhaust gas heat treatment process. Blends having low bulk modulus of elasticity with biodiesel, which is responsible for the spray pattern of the biodiesel. Biodiesel injection to the combustion chamber. Using blends with injection system modification, we can go for this advancement or retarding of the injection. So, some modification, if you go for some modification either in some in engine or in some fuel utilization, then you can use this biodiesel in higher percentage also. So, using biodiesel with some other oxygenated blends also reported, like using biodiesel with alcohols, ethers. So, it improves its ignition properties, and also with dual fueling also we can go for the dual fueling. So, the emissions and they are for controlling the emissions in the diesel engine, we can go for this blending of biodiesel, which improve the fuel ignition quality because it is having higher C10 number. And if we go for these suggested study for utilization of biodiesel into the diesel engine, sorry. So, the need for alternative and supplementary oxygenated fuels, why we need the alternate this. So, need for alternative and supplementary oxygen fuel, it at present about 67% of total world energy demand is fulfilled by fossil fuels like petroleum, natural gas, as their accessibility and convenience of use in the existing engine. So, petro based oil fulfills about 95% of your demand, transportation, domestic, etc. all. So, the alternative fuel is thus required as it is readily available, economically competitive, technically feasible and environmentally acceptable fuel, because it utilization of this reported that emissions are controlled to meet out those stringent norms of the emissions. So, we can go for it. Now, so the diesel and biodiesel requirement projections, you can see year wise projection 2010, what is your requirement in MT million tons, and this it is in 2022 you can see it is almost double, and in next 10 years it will also again double. So, by 2030 if you go for 5% blend, then we need this much amount of biodiesel, and if you go for 10% we will need this much amount, and if you go for 20% this much amount is will be needed for the mixing into the biodiesel. So, these are some processes. With the help of that, it is formed common batch process, supercritical process, microwave method and ultrasonic methods for making the biodiesel. And these are the reasons to utilize and to promote alternative fuels. So, why we go for alternative fuels? It explained that reduce of petro based oil dependency, step down toxics exhaust emissions, decreasing greenhouse gas emissions in developed countries, reducing fuel cost, enhancing of overall energy efficiency and also job creation in agriculture sector. So, that is why the use of alternative fuels is promoted from the government side also. These are the biodiesel and its production. What is biodiesel? You know that it is long chain alkyl, methyl, ethyl or propyl esters, which is derived from vegetable oil or animal fat also, and in up to 20% biodiesel is now blended. We have discussed this, now blended with petroleum diesel in many countries, and France 50% biodiesel mixed with conventional diesel fuel. So, the rapid increase in production of biodiesel from 0 in 1990 to about 1.8 billion liters in 2004. From 2005 onward, the biodiesel has been increasing all over the world. So, it is a very big challenge. Now, we can go for another oxygenated fuel, diethyl ether, and its utilization in diesel engine. So, diethyl ether is D in short DEE. It is having very high cetane number. So, you can see the characteristics. Diethyl ether is a pungent, high flammable and volatile liquid derived from the distillation of ethanol with sulfuric acid, mostly used as common solvent. So, just like ethanol in SI engine, we can go for the diethyl ether blending into the diesel engine. Approximately 5 to 10% you can directly blend into the diesel. So, diethyl ether has a high cetane number 125, very high cetane number, which is needed for a good characteristics. Then flammability limits are broader as compared to many other fuels, because diesel is having very less flammability range 0.6 to somewhere at 2.2. You have already seen it into the last lecture. So, this somewhat it is increased. So, burning velocity of the fuel is increased by using this diethyl ether. So, diethyl ether has a typically heat release rate during early cool flame generation, but it has low heat release rate for mid blue flame oxidation. So, by doing this you can control the NOx emissions also, because mid range is responsible for the NOx emissions. So, you can control if you using diethyl ether, you can note that emissions are somewhat suppressed. Ignition delay time for diethyl ether slightly less, because you know that the ignition delay is inversely proportional to the cetane number. If you blend 5% or 10% amount of DE into the diesel, so the cetane number is increased, because it is having very high cetane number. So, increase in cetane number reduces the ignition delay. A reduction in ignition delay means less fuel is accumulated and it combusted in a smooth way. So, engine life is also improved. The advantage of diethyl ether over ethanol includes its non-corrosive nature. It is very important characteristics. It is a greater heating value. It can be blended in any proportion in diesel fuel, but it is experimentally found that if you add beyond 10 or 20 15%, there are some problems are also observed, but 5 to 10% you can go for it. These are the characteristics of the diethyl ether. So, high volatility and latent heat of vaporization of diethyl ether, low auto ignition temperature. So, it is low autoignition temperature, just like diesel is having more than 250 260 degrees Celsius, it is having 160 degrees Celsius. High C10 number 125, reasonable energy density, high oxygen component, because it is having oxygen in the fuel borne oxygen. So, fuel borne oxygen, if there is more oxygen, so smoke, that is why if you go for the de-blending in diesel, the smokes are cut down, because there more oxygen available for the combustion. Then alcohols, these include methanol, ethanol, propanol, butanol. So, the OH group which replaces one of the H atoms in an alkane gives the compound other characteristic properties, means methanol and ethanol and propanol, they are having OH compound, but the molecular weight is increasing. So, they all have different properties. Specific heating value is lower than the gasoline, 42 to 43 megajoule per kg. Methanol is having approximately 20, ethanol is having 27. For the air fuel mixture, heating value is comparable with gasoline mixture. Other alcohol groups such as dihydric and trihydric alcohols are not used as a fuel in IC. So, this is the limitation of utilization of the alcohol. These are the advantages of alcohols: high oxygen contents, 35% for ethanol and 50% for methanol, high oxygen contents 35%. Then its accessibility, low cost, suitable for use in diesel engines without any hardware modifications. Then disadvantage, if you use the blending of ethanol or methanol into the diesel engine, it is its C10 number is very less, 5 to 8, which is the desirable quality of the fuel. So, and another problem is its low viscosity, because if it is used into the blends of the diesel, it will reduce its viscosity, and you know that fuel is injected through the injection pump and injectors into the combustion chambers. So, if this viscosity is reduced, there will be some wear problems, because lubricity is affected by the viscosity. And also limited solubility and miscibility, especially in the low temperature with diesel fuel, and also it is hygroscopic nature, means it absorbs water. So, sorry. So, methanol sorry. So, if we talk about the methanol, so methanol can be obtained from natural gas, has near and long term potential, it has high octane quality, 132 our road octane number and motor octane number is 95. It can be used in low concentration, 5 to 15% in gasoline to increase octane number of the mixture problem. Poor solubility in gasoline, toxicity, low energy content about half of the gasoline, high latent heat of vaporization and oxygen content contribute to poor drivability, incompatibility with some metals also. So, methanol either you can use with SI engine fuel, because it is having higher octane numbers, but these are the problems. It is very poor solubility, toxicity, low energy density, and latent heat of vaporization is very high, which is not desirable for the SI engine. It should be comparable with the petrol, not should be high, and also chemically it react with the different engine components. This all fixes the percentage of its blending. Now, come to the ethanol. So, the ethanol, it is produced from biomass, it is made from the form it from the sugar industries, sugar found in grains such as corn and others, barley, other sources of sugar to provide ethanol. So, you can go by some chemical fermentation processes like sugar cane, sugar beets, etc. It has very high octane number, can be used in low concentrations in gasoline. Most of the ethylene used in the United States today is distilled from the corn. Scientists are working on cheaper ways to make ethanol by using all parts of plant and trees just to grains. About 99% of the ethanol produced in the United States is used to make E10, ethanol 10%, or this is known as gasohol, gasoline plus ethanol mixture known as gasohol. If it is having 10% of ethanol, means a mixture of 10% ethanol and 19% gasoline. So, these are the effects on its emissions of if you use 10% ethanol. So, it is these are the some with the help of some experimental data I have conclude that I have to conclude that this carbon monoxide emission, total hydrocarbon emission and smoke emission is suppressed with the use of this ethanol or methanol in case of in diesel engine. This is for a study for diesel engine, and the NOx emission is increased because this oxygen concentration is also increased because ethanol is having fuel bound oxygen. So, NOx emission is increased, but this CO, TSC and smoke emissions are somewhat reduced. So, alcohols are unsuitable as diesel fuel for the following reasons. It is best suited for the SI engine fuel. So, why it is not suited for the CI engine fuel? The Cetan number of alcohol fuels is very low, 0 to 8, which we have discussed, which prevents their ignition by compression. So, if it is very low, then because it is a characteristic of the CI engine that it should the fuel should have the characteristic of auto ignition. So, if the Cetan number is very less, then ignition by compression is not possible, it prevents that. So, alcohol fuels have low lubricity quality, causing trouble in injection pumps and nozzles, which we have discussed that it is lubricating characteristics is reduced. And third one is its material problem caused by harsh reaction of methanol towards various plastics and metals, different components of the engine and other auxiliary components. So, methods of using alcohols in diesel engines, these are some methods. If you want to use diesel in diesel engine methanol or ethanol or butanol or any alcohol. So, these are the methods. First one is by dual injection, either through secondary injection into cylinder or into the inlet manifold of low pressure system. So, this is known as dual injection. Dual injection means if you are supplying in engine the fuel, that this is your intake manifold, that this is your diesel injection by this injector, this is the main injector. So, either the air is coming here, either you employ some injection at this intake manifold. So, ethanol can be first inducted with the air, contact it here and it is sucked with the air into the cylinder, and fuel is diesel is injected from with the help of some injection device directly into the combustion chamber. So, this is known as dual fuel mode. Here you are injecting fuel into the intake manifold. So, this is one is by dual injection, either through secondary injection into the cylinder. Secondary injection means you directly inject the fuel. And another one is using co-solvents such as ethyl acetate added increased range of miscibility. Then chemical ignition accelerators, we can go for some chemical like organic nitrates, alcohol fuels, and then 5 to 20% additives are required for knock free operation, but additives are expensive and because they contain nitrogen they also increase the NOx emission. So, these are the some methods with the help of that you can use the fuel into the diesel engine. So, this is all about in this lecture. Thank you so much.